introduction.
Hello and welcome to this video on the topic of gear and gear trains, and a very important topic in GATE ME. Now, before we look onto this diagram, before we fill this diagram with various details, let us talk about what are gears, and then we'll go to what are gear trains. Before we are, after we are clear with what are gears. Now, what is a gear? What are gears basically? The gears are basically power transmission machine elements. So you can transmit a power from one machine element to another machine element with the help of a gear. For example, if you look at this diagram, this is the shaft. This is the shaft. This is the axis of the shaft, right? Now, from this shaft, if I have to, this is a very simple kind of a setup. This is the another shaft. Now, both the shafts are parallel. This shaft is the driving shaft, and this shaft is the driven shaft. Right. Now, initially, the driving shaft is connected to a prime mover. Let us say this is connected to a motor. This motor is giving the rotational power to this shaft. Now, from this shaft, I want to transmit this rotational motion onto this shaft. Now, this is not connected to any prime mover. No engine, no motor, nothing. Now, how do I transmit the power? One way of transmitting power is by putting belts and pulleys, right? So, we studied about belts and pulleys. The belts and pulleys are also elements which transmit power from one machine element to the other machine element. Similarly, I can use gears. Now, why do we need gears instead of belts and pulleys? See, there are some obvious advantages. First of all, belts and pulleys, they offer a negative drive. There is a lot of slip, the efficiency is low, right? But in gears, you can transmit higher power with higher efficiency and with positive drive. There is no slip in this. So, if I mount a gear onto this, now this is the gear, this is the top view, and these are the teeth of the gear, right? Now this rotates, the gear rotates. The gear and the shaft are having interference fit, so there is no relative motion between the driving shaft and the gear mounted on top of it. Now after this, I again install a gear onto the driven shaft, like this. Right? These are the teeth on the gear of driven shaft. Now again, there will be no relative motion between the gear and the shaft. Why? Because they are having interference fit. There is a key mechanism which keeps these gears in position on the shaft. Now, driving shaft rotates, it makes this gear rotates. This gear is in connection with this gear. Now, the rotary motion from motor comes to this shaft. This shaft moves, this gear moves. This gear moves, it makes this gear moves. Now this gear again moves this shaft. So this is how the power is transmitted from shaft onto the gear, from gear to gear, and then from gear to shaft. Okay. If you look at the front view of this, now this is the plan. If you look at the elevation of this, elevation can be found out to be like this. So if I take the projection, right, now this will be a gear, and again this is the second gear, and these are the shaft hubs. You can draw cross section over here. Okay, now you see I am not putting any kind of teeth on this. You can put teeth on this like this. Okay, you can put teeth on this like this. Right, now I'm just indicating them that these two gears are in contact with each other, they're in mesh with each other. Now, this is rotating in this direction, so this will rotate in the opposite direction. So this is one major rule you have to remember, that when two gears are in direct mesh, they will rotate in opposite directions. So if it goes in the clockwise, that will go in the anti-clockwise direction. Now this is the driving gear. Now driving gear is commonly known as gear, and the driven gear is known as the pinion or the follower or the driven gear. So this is the basic layout of a gear system. The gear, power transmission element between two machine elements. Now this setup is basically a gear train. Okay, so this is a gear train setup. Now this particular kind of gear train is called a simple gear train, in which the power from one gear to the pinion is transmitted between two parallel shafts. Now let's come on to this diagram and try and fill it up. See, I've just drawn two teeth on a gear. It can be a gear or a pinion, whatever it is. Right now, let me put these points. What are these points? These are pitch points. So what is the pitch point? Pitch point is that point at which two teeth are meeting each other, they are in contact with each other. So if I draw a locus of these points, I will get a circle. I'll get a circle. Now this is an imaginary circle. This circle is called pitch circle. Right? Now, the radial distance, or you can say, let's first of all say that let us say this is the center of the gear. Now the radius of this pitch circle is known as pitch radius, and the diameter of this pitch circle will be known as pitch circle diameter or PCD. So, and commercially, if you have to specify a gear size, it is specified in terms of its PCD. So if somebody says the gear size is 50 mm, so 5 in front of 50 indicates that it is talking about a diameter. Now what diameter it is PCD. That is the pitch circle diameter. Right. The radial distance between the pitch circle, and let me draw another circle which is the locus of the top surface. This is called the addendum circle. This is called the addendum circle. Okay. Now the radial distance between pitch circle and the addendum circle, this radial distance, this is called addendum. So if you have to find out the radius of the addendum circle, that is RA, so RA is equal to pitch circle radius plus the addendum. If I need to find out the diameter of addendum circle, then it will be pitch circle diameter plus twice of A. Right. Now let me draw the circle at the bottom. Now this circle is called a addendum circle. Okay. And the radial distance between the pitch circle and the addendum circle is called the addendum. So this is addendum and this is addendum. Let me put this as capital D, so there is no confusion between the addendum and pitch circle diameter. Right. So now let me take this as RD. So RD is equal to R minus D. Okay, so if I have to find out the addendum diameter, then it will be PCD minus 2 times addendum. Right. Now, this point on this tooth and the same point on the consequent tooth. Let us say this point. Okay. Now, the distance between same points on consecutive tooths or teeth, sorry, is called pitch. It's called pitch. So between this point and this point, the distance is called pitch. Similarly, if I take the distance between this point and this point, then this will also be called as pitch. Okay. So now we have defined pitch. Pitch is the distance between same points on consecutive teeth, right? And the distance between these 2 points, this is known as the tooth gap. This is known as the tooth gap, right? So this is the very basic terminology of gears that we will be using in the chapter. That's it. Thank you.